So now we'll talk about the urinary system. The urinary system has multiple functions. It eliminates waste products, particularly nitrogenous wastes, which are byproducts of metabolic processes. It eliminates toxins and eliminates drugs. It's also involved in regulating homeostasis. In fact, this is the primary system involved in homeostatic balances. It takes care of water and electrolyte balances. It takes care of acid-base balance, blood pressure, blood cell production, and activation of vitamin D. Now, the organs of the urinary system, it's fairly simple structurally. You have the kidneys. You have ureters, which are tubes that lead from the kidneys and carry urine to the bladder, and the bladder stores the urine until we micturate or urinate, and then it goes through the urethra to the outside. Now, I say that the structure is simple. The gross structure is simple. The internal structure of the kidneys themselves are rather complex. Location of the kidneys are outside of the body cavities, so they are said to be retroperitoneal. They are located on the dorsal wall of the body, and they lie underneath those two floating ribs. So if you were wondering what those floating ribs are for, they are largely for the protection of the kidneys. Now, we have one kidney that is a little bit more exposed than the other. The right kidney is lower, and that is to accommodate the position of the liver. Kidney features. We have a indentation in the kidney, just like we have an indentation in a kidney bean. And this is where the urethra, or the ureters, my apologies, the ureter exits, where blood vessels and nervous tissue go in and where blood vessels exit. So that indentation allows for all the feedback to go into and out of the kidney. There is a structure on top of each kidney, which you don't see in this image here, but it is the adrenal gland, and we'll see that in just a moment in a different view. In terms of how efficient the kidneys are, we only need 40% of their overall function. So if you were to lose a kidney, you'd still have 50% of your function, and in fact the remaining kidney would enlarge, and you'd gain back to 80% of the original function. This is why we are able to donate a kidney. Now, the functional unit of the kidney is something called a nephron, and each kidney contains about 1 million of those. Now, as we age, we lose nephrons and they are not replaced. But again, we have a massive reserve of function that allows us to lose some without really having any major consequences as a result. The kidney has several coverings. It has a fibrous capsule which surrounds the kidney. This is a tough material that is water resistant or waterproof. We have perirenal fat, and this fat protects the kidneys from damage if it were to be hit in some way. And we have renal fascia, which is an outer layer that holds the kidney pretty much in place. Now, it is possible that someone can lose a lot of weight and the renal fascia will end up being a little loose, and you can get something called a floating kidney as a result of that. Here's a model of the structure, and you can see that there is a ring of lighter tissue on the outside. That is the renal cortex, and that contains the glomeruli. And then we have the medulla, which is subdivided into triangular spaces and columns that lie in between. The triangular spaces are largely collecting tubules, and the columns in between contain vessels that help us regather materials from the filtrate that we produce. So the pyramids are these triangular divisions. At the end of each pyramid is a structure called a papilla. And this is where urine actually drips into another structure called the minor calyx. And the word calyx is Latin for cup. So the calyx collects, and we have several minor calyxes which feed into a larger structure called major calyx or bigger cup. And then all of that feeds into something called the renal pelvis, which eventually becomes the ureter. Here is a different version or view of the same image. This is just a dissected kidney, and you can see again the lighter tissue on the outside, which is the renal cortex, and then we can see the darker renal pyramids. In between each pyramid is the renal columns, so you can get a sense of how that structure looks. Now, there's an ample blood supply that goes to the kidneys. In fact, about a quarter of your overall blood supply is filtered through the kidneys each time, each minute. So 1/4 of the total blood supply of the body passes through the kidneys each minute. That is as much as goes to your brain. And this is supplied by renal arteries, with each kidney with an arterial blood supply. Again, damage to the renal artery can result in someone bleeding out fairly quickly. So what is the function of the kidney? We've already discussed that. Its function is to filter nitrogenous wastes and other substances, and to make urine. What are the components? We've talked about the kidneys, the ureters, the bladder, and the urethra. Where are the kidneys located? They are retroperitoneally located. How much kidney function do we need? Only about 40% of overall function. And how much blood flows to the kidneys? About a quarter. Structurally, you need to know what the cortex is and the medulla, what the pyramids are, what are the papilla, and what are the calyces. Now, the microscopic structure, this is a little more complicated than the gross structure of the system. The microscopically, nephrons are the microscopic structure and functional units of the kidney, and they're made up of several different sections. There is something called the renal corpuscle, which is Bowman's capsule, which is a waterproof cup-like structure that surrounds another structure called the glomerulus, which is a very leaky network of capillaries. So we have Bowman's capsule and the glomerulus, and then from Bowman's capsule we have tubules that are the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule, and collecting tubules. And we'll talk about each of those in kind as we go through this presentation. Now, different things happen in each of these areas. The glomerulus filters blood. The Bowman's capsule collects that filtrate, and then the renal tubule modifies the filtrate to form urine. If you were to look microscopically at a kidney, you would see that the nephrons lie largely in the cortical area, and we have cortical nephrons. We have some that are closer to the medulla, and these are called juxtamedullary nephrons. Nonetheless, these are both in the cortex. Now, the glomerulus, its structure is that it is a knot of capillaries, and these are very leaky capillaries. They contain fenestrations or windows, and they are covered with cells called podocytes, which have interacting little feet or fingers that interlace, that allow materials to leak out without allowing large things like red blood cells and proteins to leak out. The glomerulus sits within that capsule, and the capsule is really the first part of the renal tubule. Capsule is waterproof, tightly sealed around the blood vessels that go into it. And it looks something like this. You have a blood vessel going in, that's the afferent arteriole, and you may notice that it is actually smaller than the one coming out, bigger than the one coming out, called the efferent arteriole. That is so that more blood can flow into the glomerulus then can flow out. That maintains a pressure that allows us to filter material. Once we filter it, it goes into this Bowman's capsule, and from the Bowman's capsule moves to the proximal convoluted tubule. This is pretty much what the nephron looks like. Internally, somewhere buried in here are the capillary beds with the fenestrations or windows, and these are the podocytes laying on the surface with their little foot processes, again interlaced in such a way as to prevent large materials from passing through. The nephron anatomy contains then renal tubule that extends from the glomerular capsule or Bowman's capsule. There is something called the proximal convoluted tubule, a hairpin turn area called the loop of Henle, and the distal convoluted tubule. Different processes of urinary production occur in each of these areas. This is more or less what it looks like. Again, you have the Bowman's capsule, you have the glomerulus, you have then this tubule, which is surrounded by capillaries, which are involved in reabsorbing materials that are released or filtered out. So we have this proximal convoluted tubule, this little loop here is the loop of Henle, and then we have the distal convoluted tubule, which ultimately carries the now modified urine to this collecting duct. Nephrons are associated with two capillary beds, in fact. There is the glomerulus, which does the filtering, and then the peritubular capillary bed, which collects water and other materials back into the bloodstream as filtrate runs through the tubules. Now, this is significant because without these peritubular capillaries, we would be urinating constantly and actually wouldn't live very long, because we filter out about 98, 99 liters of filtrate per day. So the I apologize, actually that's about 180 liters a day. The glomerulus feed and drain by arterioles. We have the afferent arteriole, which feeds the glomerulus. It is the larger of the two vessels and helps generate high blood pressure or high pressure. We have the efferent arteriole, which receives blood that is passed through the glomerulus. It is smaller and contains blood with less plasma than the circulating blood. This area is specialized for filtration. High pressure, because we have the larger afferent arteriole than the efferent arteriole, forces fluid and solutes out of the blood and into the glomerular capsule. So again, you can see this structure. Now, this is a good place to stop. We will pick up here again in our next presentation.